Now, how do you convert a decimal number to its binary equivalent? In this video, we are going to make you understand this concept clearly. And we begin with this example, 25 to base 10. Remember, this is a decimal number, and we're supposed to convert this to its binary equivalent. So the first thing, we shall write 25, then we divide this 25 by the base of a binary number. Remember, the base of a binary number is just 2. 25 divided by 2, notice that it is 12.5, right? So the thing we shall do here, we shall pick the number when multiplied by 2 will give us a whole number that is just closer to 25. And notice that it is 12. 12 multiplied by 2 is 24. Now to get the remainder, we subtract 25 minus 24 and we get the remainder as 1. Now something to note here is that if you have an odd number, you are dividing an odd number, your remainder will always be 1. And if it is an even number, your remainder will be 0. Next shall be 12 divided by 2, it is 6. And since 12 is even, the remainder is 0. We do the same for 6 and we shall have 3, the remainder is 0. Then 3, we shall divide 3 by 2, get 1, the remainder will be 1 because 3 is odd. Now next it shall be this one, 1 is odd, 1 divided by 2 is 0, and the remainder is 1. And we are done because we've got to 0. So in representing this number, we shall write these numbers from the bottom to the top because the number at the bottom is the most significant and the number at the top is the least significant. So we shall write this as 1, 1, 0, 0, 1 to base 2. So 25 to base 10 is the same as 1, 1, 0, 0, 1 to base 2. Simple, right? Next we have 40 to base 10 and we convert this to binary. So begin by dividing 40 by 2 and we get 20. Because 40 is even, the remainder shall be 0. Our next number shall be this 20. Dividing this by 2 we get 10, the remainder is 0. Next shall be 10 divided by 2, we get 5, the remainder is 0. 5 is odd, so our remainder shall be 1. 5 divided by 2 is 2 because of 4, and the remainder is 1. Next, it shall be this 2, and we divide the 2 by 2, we get 1, the remainder is 0. And lastly, we shall have 1. 1 divided by 2 is 0, and the remainder is 1. Notice that our final number will always be 1 because the final result shall be 1 divided by 2 in all the cases. So we write these numbers from the bottom to the top and we shall have 1, 0, 1, 0, 0, 0 to base 2. So 40 to base 10 is the same as 1, 0, 1, 0, 0, 0, 0 to base 2 as its binary equivalent. Now let's handle another example. 0 to base 10 to its binary equivalent. We divide 0 by 2 and we get 0. The remainder is 0. So 0 to base 10 is just the same as 0 to base 2. Next we have 156 to base 10. And this is interesting. We convert this to its binary equivalent. We begin by dividing 156 by 2 and notice that 156 is even, so our remainder will be 0. 156 divided by 2 is 78 and the remainder is 0. Next is 78 divided by 2 we get 39, the remainder is 0. 39 is odd, so our remainder shall be 1. Next we shall have the same 19 divided by 2 and remember 19 is odd, so our remainder will always be 1. Then next we shall have 9. 9 divided by 2 is 4, the remainder is 1 because 9 is odd. Next is 4 divided by 2, we get 2 and the remainder is 0. Then 2 divided by 2 we get 1 and the remainder is 0. Last, it is 1 divided by 2, we get 0 and the remainder is 1. Easy. Then we write these numbers from the bottom to the top and we shall have 1, 0, 0, 1, 1, 1, 0, 0 to base 2. So 156 to base 10 is the same as 1, 0, 0, 1, 1, 1, 0, 0 to base 2. Now what if we have a number with decimal points? How do you convert it to binary? Let me take you through this in a simple way. The first thing, we multiply the number by 2 and notice that 0.625 by 2 is 1.25. Then we subtract 1 from 1.25. So our integer part shall be 1. Then 1.25 minus 1 is 0.25, right? So we pick the same 0.25, we multiply it by 2 and we get 0.5. Notice that our integer part is 0 and 0.5 minus 0 is 0.5. So we shall have 0.5 times 2, we get 1 and our integer part is 1, our decimal part is 0, and that is our final step. So in representing this number, we write them from the top to the bottom. So it shall be 0.101 to base 2. So 0.625 to base 10, when we convert it to binary, it shall be 0.101 to base 2. Next we have 0.375 to base 10, and we convert this to its binary equivalent. First we multiply it by 2 and we get 0.75. Our integer part is 0. Our decimal part shall be 0.75. We multiply the same by 2, we get 1.5. Our integer part is 1 and we are left with 0.5. 0.5 multiplied by 2, we get 1.0. Our integer part is 1, our decimal part is 0, and our number is 0.011 to base 2. Easy, right? Now, what happens if we have a mixed fraction? For example, 13.625 to base 10, and we are supposed to convert this to binary. It is very easy. We shall write that this part shall be for our integer, then from this side we shall work out the fractional part. We begin with 13 divided by 2, we get 6, the remainder is 1. 6 divided by 2 is 3, the remainder is 0. Then 3 divided by 2, it is 1, the remainder is 1. Then 1 divided by 2 is 0, the remainder is 1. We write these numbers from the bottom to the top, and we shall have 1101 to base 2. We move to the fractional part, and our fractional part is 0.625. We multiply this by 2 and we get 1.25. The integer part is 1. Next it shall be 0.25. So it shall be 0.25 multiplied by 2. We get 0.5. The integer is 0. The next number shall be 0.5. 0.5 multiplied by 2 is 1.0. The integer is 1. And the remaining number is 0. So we are done at that point. So we write these numbers from the top to the bottom, and we shall have 0.101 to base 2. So for us to have a complete answer, we shall combine these two, and in combining these we shall have 1101.101 to base 2 as the binary equivalent of 13.625 to base 10. Now what will happen if you have a recurring decimal? 0.1 by 2 is 0.2, integer is 0. 0.2 times 2 is 0.4, the integer is 0. 0.4 times 2 is 0.8, the integer is 0. 0.8 times 2, it is 1.6, integer is 1. 0.6 by 2, it is 1.2, integer is 1. 0.2 by 2, it is 0.4, the integer is 0. And notice that from here, it recurs again because it goes back to 0.4 and it keeps continuing. So, what will you do with this? When you have such a scenario, you don't keep multiplying because you'll never get to the end. So you just decide your final point and you write just your decimal numbers to that point. So for our case, we shall have 0.1 to base 10 is approximately 0.0001100110011, and it keeps continuing, and this is basically to base 2, and this is the final result. If you've enjoyed and understood, go ahead and like this video and don't forget to subscribe to this channel. Thank you for watching.